learned about the 3 states of matter, but did you know that there's a 4th state? It's called plasma, and it's led to some pretty cool breakthroughs in technology. While most of the world we know is in these 3 states, plasma actually makes up 99.9% of the universe. Some examples of plasma would be lightning, stars, and aurora, and even fluorescent lights. So what is it? Plasma is an ionized gas. It's something like a soup of ions, electrons, and neutral atoms. For an example of ionization, we're going to use a simple atom known as hydrogen. When atoms are subject to heat and energy, they move around really fast until eventually an electron separates from the atom, leaving the nucleus and electron to move independently. After ionization, plasma can conduct electrical currents and react to magnetic fields. Plasma physics is studying how plasma interacts with electricity and magnetic fields and utilizing that. Plasma can be applied to areas of space physics, accelerator physics, and fusion energy generation. The purpose of fusion energy is to make an unlimited, sustainable energy source. Fusion uses a fuel that are isotopes of hydrogen. Hydrogen has 1 proton and 1 electron, while deuterium, extracted from seawater, has an extra neutron, and tritium, extracted from lithium, has 2 extra neutrons. These extra neutrons are important for the fusion reaction. Plasma energy research has been in development since the 1980s, going through multiple different designs in order to harness plasma energy. The reactors have the main purpose to heat and confine the plasma so that its movement can be controlled and the particles are more likely to collide. ITER in southern France is the largest plasma physics experiment in the world, about the size of 60 soccer fields. The reactor design is the tokamak, which utilizes magnetic confinement fusion to keep the plasma in a donut shape known as a torus. The problem with the torus shape is that the magnetic field is stronger near the center. To solve this, a transformer is added to the center of the torus, which creates another magnetic field, evening out the distribution of the plasma. The torus is a vacuum chamber filled with hydrogen gas, which is heated by a strong electrical current. This causes the ionization, making the plasma. The particles of the plasma are kept rotating around the torus due to magnetic fields made by the toroidal and colloidal field coils. These magnetic fields keep the plasma particles away from the walls and the machine and close together. Many particles moving at high speeds in a small area increases the probability that they will be able to overcome the electrical force pushing them apart so that they fuse into a heavier element. Deuterium and tritium fuse to form helium and a neutron, as well as releasing energy. This energy is absorbed as heat in the walls of the vessel, which is then used to create electricity. Fusion energy would be an incredible breakthrough because it would provide virtually unlimited clean energy. It is much safer than other forms of energy because its fuel and waste are not highly radioactive and it can't melt down or explode. If a working fusion reactor were made, it could provide 4 times as much energy as nuclear fission. Unfortunately, current reactors are only proofs of concept. They're expensive and a successful one has yet to be built. While the technology seems to be perpetually 30 years away, progress is always being made. Funding and research into fusion technology could bring us closer to a sustainable energy source.